Good morning, class. I don't know, you're still asleep. So, I was asked to do a short history of the internet. I'm not here from the government, and I don't know whether I'll help or not, but I'm going to give a short history of the internet. So why? Why was this thing done that is now called the internet? Well, it's a divergence of views. We just heard Diane said it was to protect us from nuclear attack. Some people believe that, some people don't. Larry Roberts says that it was all to share big, expensive computers. Paul Barron at the same time was showing us cute little charts of how messages would go through even if half the routers in the world were destroyed, as long as you had enough redundancy. I expect that the bottom line is that it wasn't that the reason that the ARPANET was done, because of who it was done by, Larry Roberts and company, funded by, it was not that it was to protect us against nuclear war, but that was an excuse. That was an excuse that was used within the Defense Department to say, we'll spend the money on it. But this is a discussion that will go on for quite a while. Suzanne Wolf this morning asked me to try and put to bed the myth that it was designed to survive a nuclear attack, and I can't do that, but she'll attack me later. So what was there at the time? What was the environment that the people that were working on this were confronted with? It was the phone net from the phone company, TPC. If you don't know what TPC is, then you're not a proper geek. It's a circuit-based environment, assumed a simple and predictable interconnection between the endpoints, the black phones, assumed a requirement for quality of service, a particular quality of service, and it was assumed that everything was carrier provided. Nothing was these random ad hoc things. It was carriers, and it was voice. Maybe a little data pitched in, but it really wasn't. So what was wrong with that? Nothing, and if all you wanted to do was talk to Joe and you just wanted the one service. Here's a question. What does the fast busy signal mean in the telephone network? Out of trunks. Well, that's the technical reason. That's the technical explanation. But the philosophical explanation is actually a little bit different. It's that the phone company has decided that rather than providing you with a service of less quality than they have determined that you should get, they will provide you no service at all. Can you spell socialism? And if you liked what AT&T was providing, remember this is pre-breakup, if you liked what they were providing, you thought they were innovators, then there was nothing wrong with the network that was there. Well, a lot of people didn't agree with all of the above. They wanted something different. So they went off and then didn't make their own, didn't build their own. They made it on top of what was there. And actually that was an important detail. There are a bunch of unrelated efforts, and they were completely unrelated efforts for a long time. Paul Barron and Larry Roberts didn't know each other, didn't know about each other's work, even though it was effectively the same, until quite late in the game. Larry claims that Paul's work has nothing to do with what came out of it, that came out as the internet, and others claim that it does, but who knows. So there's a lot of miscellaneous efforts going on, and it was a lot of fun. It was churned along in various low levels of ARPA grants for a long time, and as Ted Kennedy put it, the RFP for the Interfaith Message Processor was won by BBN in '68. He got it a little wrong in his congratulatory message. We're up to 4 hosts in '69 and public demo and email and all that kind of stuff in Washington, D.C. in '72. But what was it that was being made here? It certainly wasn't what was already there, which was that telephony thing. So what was it? It was packets, first of all, datagrams. Very weird concept in the phone world, because with packets you can't actually predict where they're going to go, because their decisions are made ad hocly at the individual devices and individual routers. So there's no predictability in this thing, therefore there can't be any quality of service. So it couldn't possibly work, but try it anyway. The uber goal, according to this list of bullets here, is from Vint Cerf, who said that these were the basic goals for the Internet Protocol Suite. First of all was to use existing networks. This is the uber goal. This was the goal above all goals. Don't build your own network, because if you build your own network, you'll never get it done. It's too expensive. But if you just use what's there, and understand that what's there is not consistent, then you can switch out the networks underneath it as you go, as they evolve, and keep going. So you use existing networks with multiple operations, management systems and distributed management and all of that. Note that that first bullet is something that the ATM people didn't understand. The ATM network, the concept behind the ATM network that the ATM Forum and the like was pushing for many years, was to be the network. Not a network, but the network. I once asked John McQuillan to ask his ATM Year 3 or whatever it was meeting whether ATM was the last networking technology. Because, of course, if you're writing your applications to talk directly to ATM, it had to assume that what the network was underneath it. And if that changed, you have to rewrite all your applications. So, of course, this had to be the last networking technology. And, of course, people had to stop thinking. John refused to ask that to the group. I don't know why. We'll get back to John a little bit later. Second goal, the first of the sub-goals, was survivability. So maybe this nuclear attack thing had some currency, but it was survivability, not necessarily in the face of nuclear attack, but at least in the face of router failure. Multiple types of communication service. It wasn't just voice. Variety of network types, Ethernet, token ring, et cetera, et cetera. Distributed management. Nobody's going to run the whole thing. Cost-effective, low effort, accounting for resources. Didn't do the last one real good, which is probably actually quite nice because that meant that the big carriers stayed out of the game for quite a while because they couldn't figure out how to get it to pay. Note that there was no security goal, no quality of service goal, and no efficiency goal. Some of this was on purpose. The QoS goal, it's not clear why there wasn't one, but there certainly wasn't one. There's hints in the IP header, but there's nothing real. No security goal. David Reed says it's because he was told not to do that. They wanted to put in end-to-end security at the very beginning, but they were being paid by DARPA to do this stuff, and they were told, well, they don't really need that because it actually didn't fit into DARPA's concept of what security was, which was compartmentalized. And there was no efficiency goal. But there was end-to-end. And that's a key feature was that the network was out of the way. You talked from one end to the other end, which meant that you and I could create our own application and trundle along with it, and nobody else had to, we didn't have to get permission from anybody else, and nobody else cared. It was just there, we were just packets over the net. A rather important feature which we are not doing so well these days with. Efficiency wasn't a goal. This is Bob Bradner a couple of years ago. Saying that efficiency wasn't a goal. Adaptivity is a much more important goal. Simplicity and uniformity is important. It is not efficiency. This is a complete puzzlement to the phone world. In the IETF, we have this protocol called Megaco. At ITU, that's called H248. It's a way to break up a phone switch into a controller and a bunch of clients. The IETF defined this protocol along with the ITU. It was an interesting experience. Something about twin brothers who don't like each other. It was an interesting challenge working in that kind of environment. So we came up with this protocol that had a ASCII communication, just like the web or just like everything else. It's an ASCII communication to do the controls. So you can just watch it and debug it by just looking at it. Well, it was not efficient enough for the phone people. They had to have a binary version. So if you go look at the standard, there's two appendices, one for ASCII, one for binary, because it was 3% more efficient to do the binary version. And that was what they were focused on. Because they were mired in the old world where they've got 9,600 baud lines, they have to fill them to 93% utilization. That's not the world of the internet, and it really never has been, even when we were overfilling the 56K lines that Eric talked about earlier, overfilling those in a matter of minutes. We were never concerned with efficiency, we were concerned with flexibility. So what did they being the traditional networking world, think the internet was, this new thing, this new datagram thing was? Well, they thought it was a bumblebee. Because by definition and by design, according to aerodynamic theoreticians, bumblebees can't fly. IBM in 1992 said that you, quote, you cannot build a corporate data network out of TCP/IP, end of quote. By definition, you can't do it because a corporate data network has all of these quality of service controls in it. And TCP/IP doesn't have these controls, so therefore you can't build a corporate data network out of TCP/IP. Now that's at the same time as other people in IBM were actually doing some pretty good work in the space, but official corporate policy was this bird wouldn't fly. Well, I don't know how many of you here have ever been to a share users group, the old IBM share users group. I used to go to that. I was a manager of one of the sub-projects in there, a TCP/IP project. And at share, you get little stickers to put on your badge to indicate what you're interested in. If you're interested in communications, it's an octopus. Interested in numerically intensive computing, it's a circle with a 42 in it. And if you don't know what that means, you can't get one. And if you're interested in TCP/IP, we decided to use a bumblebee. Because IBM said it wouldn't fly, Bumblebee didn't give a crap, kept flying. IBM said TCP/IP wouldn't fly, we didn't give a crap, we kept going. The other thing they thought it was something with all the plumbing hanging out. This is a complete weirdness to the phone world. The phone world is a service. It provides this connection to that connection, and what goes on inside is none of your business. And yet this internet thing, this packet network thing, is everybody could see what was going on. And boy, was that weird. Feature. Carrier is moving packets. Carrier is not providing higher level services. Carrier can, but I don't have to get my services from the carrier. I can get my services from anybody on the net. This is a message to an IETF mailing list 2.5 years ago from one of the phone people. One would have thought he would have figured out by now there's no binding. No binding between the IP carrier, the ISP, and the services that are being provided. I don't need to if I want to do voice over IP, I don't need to do that using my IP carrier, my local ISP. I can do it by using a voice over IP carrier anywhere in the world, or not at all. I can use it direct connections. That's something that the phone companies don't really understand still. We'll get more to that. Basically, the ISP doesn't profit from the content running over their network. All it is packets. It's a commodity thing. It's packets. Telcos don't really understand this. They want to be in the picture. AT&T last year said they were building a content-aware next-generation network. Content-aware, so it would help you move your content around. Of course, also it would make it so that only the content that they liked moved around. There's no connection between that and budgeting and all. Dave Clark put this as that we don't know how to route money. We know how to route packets, but if you're getting good service from your ISP in order to talk to your bank, there's no way the bank can pay your ISP money to provide that good service. We don't know how to route money. Well, so far that's actually an interesting tension we have in this internet thing, and it's been there all along, that we don't have the carriers are not in the value chain other than for moving packets around. Unless they happen to be providing particularly good service, higher level services, then we might buy the services from them. Another feature of this point is that there's no tapping point. The FCC on this Thursday is going to be discussing regulating voice over IP. There was a request from the Justice Department, from the FBI, and then from other groups as well in the federal government, to make it so that voice over IP falls under CLIA, the wiretapping statute. But that's almost perfectly the wrong thing to do. I'm not talking about the morality of wiretapping, which other people do. It's the wrong thing to do because I don't have to involve the carrier, any carrier, in my voice over IP session. I spent most of last Friday on a conference call, a video conference call using iSight camera on my Mac to talk from Boston to Washington. Nobody in the middle knew I was doing that. There's no carrier that could have wiretapped that because there's no carrier involved. If indeed Justice Department, the FBI, and the Drug Enforcement Agency, which is the ones which are pushing this right now, want to wiretap, they can't wiretap the service because there's nothing the carrier can do to find that service. It's just packets. And it's probably masquerading as port 80 anyway, so they can't see it at all. The only logical thing for them to do is to go down and tap the net itself. And watch for this to happen. Watch for Congress to be asked to extend CLIA to wiretap your nets so that you're required to hand off packet streams to the law enforcement agencies. This is something that the law enforcement people are having a very hard time understanding. that there is no requirement for me to use a carrier to get a service over the net. But they will learn, because they will try what they're doing now and will fail. So governments, not just here but all over the place, don't understand this concept. And then there's this importance thing. One of the byproducts of this datagrammy thing that we did is that nothing's more important than anything else on the fundamental. You can mark the packet saying this packet's more important, but what do you mark? Well, you damn well better mark your routing packets, but we've seen what happens when you don't do that. But other than that, what do you do? There's this Internet Emergency Preparedness Working Group in the IETF that I co-chair, and it's just a stunning split in the miscommunication between the regulators and the ISP folks in that working group. It's just breathtaking. And Bill knows this rather well, that the regulators come in and say, well, you have to make sure that emergency communication takes precedence over everything else. Well, but they can't take precedence over routing, obviously. But it's also irrelevant in the big backbones these days, because there's enough capacity so you don't have to do anything. It actually gets in the way. It adds vulnerability for denial of service attacks. And on the edges, the backbone ISP doesn't control the edges. So there's no way to get that control all the way through. But that doesn't stop the regulators from trying. And the regulators are likely to require you to give priority to emergency traffic. Whether you can do it or not is irrelevant. The regulators tend to be technology atheistic. They don't understand the technology, and they tell you the rules you have to follow independent of whether it actually can be done. How about differentiated services? This has been a pipe dream of a lot of people for a long time, is ISPs could get into the value chain by charging more money for better quality. Well, the problem with charging more money for better quality is that the internet works too often. Mike Odell quaintly put it, it fails to fail often enough so it looks like it works. So when I'm doing my voice over IP calls from my office or from my home over my Comcast net, it just works almost all of the time. So here's a question. How many here know what an integrated access device is? Let's see whether you're awake. You all should know that. Integrated access device, that little box you put on the end of a DSL line or a cable modem, which has a phone jack on the side you plug your phone into, and an Ethernet jack in the back you plug your data network into. And they want you to plug your phone into the phone jack and make a call, and they know when you're making the call because it's a special connection, and they charge you for the call. Now, if you get an Ethernet phone, you plug it into the Ethernet jack, you make a call, they don't know you're making a call, they don't charge you for it. That's an intelligence test. I don't think enough people are going to fail that test to make this a viable business. But they have hopes. The carriers have hopes. Dave Clark said he was talking to one of the cable companies about this, about the fact that you could just plug an Ethernet phone in and it would just work. And the guy thought for a minute, he said, well, I know how to make that not work. It's probably not the right approach, but that's the approach that they had. So I talking to the Harvard person in charge of the Harvard phone network, and she says, yeah, well, this voice over IP stuff, I don't know. The fact that it works makes me nervous, because it shouldn't work. I can't prove that it's going to keep working. So she doesn't know whether she actually wants to roll it out. It works just fine. We've got it in a couple of buildings, and it's doing just fine. But she doesn't know whether we want to roll it out because it shouldn't work. So now I've got the obligatory topology maps. We've got 69, 71, 77, 91, minus the regional nets, of course. This was the backbone folks, and they were backbone centric. Little story behind this picture. This is an alternate view of 91. The first time I saw this picture was in Vancouver, British Columbia, at a CA Net meeting up there, and the folks from MCI came up. Now, these weren't the geeks from MCI. These were the next level up. They're marketing people who might have understood IP if you pronounced it carefully, but couldn't get much further than that. So they came up and they said, this is maturing. This is now a service. Back to that picture of the Pompidou Art Center. This is now a service. The insides aren't hanging out. So we're going to draw this as a cloud, and we're going to draw the connections to it, and you don't need to know what's inside. They were extremely puzzled when we tried to explain what traceroute was. They couldn't really get this. They didn't really like it. They went back to their technicians and asked them to block traceroute. the response was, sure, if you actually don't want the network to run. The other thing that was kind of annoying was this particular picture was being presented in Canada, and this was a network. It was a big black cloud hanging over Canada. The Canadians didn't like it. And this, of course, is the famous NSFNet PR graphic. Go on to Google, the Google image search, and look for NSFNet. This graphic is used by dozens of consulting companies to prove their networking prowess. It has nothing to do with what they're doing, but it makes them look good, I guess. And this is about the time that Al Gore was being claimed to invent the internet. As we saw earlier, Al did help fund the high-performance computing initiatives who actually got us to where we are. Didn't invent it, he just provided the money. It's not a bad thing to do. And here's one version of where we are today. This is a topologically correct view of the internet architecture. And here's another one. This is the more pretty view. I can't figure a damn thing out of this, but it's really cute. So, psychological timeline. So we've been following this internet thing, and what's it been doing? I remember back there, I was playing around in this thing for a long time. I got my first account in late 70s on Harv 10 on the ARPANET, and we were punking around in there, and it was a great deal of fun. Had a lot of good time. In those days it was geeks and students. Actually, in those days it was just geeks, because actually we at Harvard could not let the students on the ARPANET, because at that point the ARPANET was only for government-funded research. So we had to block the students out until CSNet came along. CSNet made a deal with the ARPANET which said, okay, we can let any student or any faculty member or any staff member at Harvard use email. Not FTP, but we could use email. So it was growing along there. And then a bunch of companies started joining, and I chose IBM and DEC particularly because those are two companies where all of their corporate push was for proprietary protocols. And yet there were major groups in both of those companies that were pushing the internet and pushing IP very strongly. It was not the corporate direction, but there were some very strong people there. There was a little burp in 1988, fall of 98, November 98, when the Morris worm was the top news story for 3 nights in a row, which raised the profile of this internet thing quite a bit. And Tom Brokaw got up there and told us all to change our passwords. He didn't know what that meant, but he did it anyway because it was in the script. Then along came the web, and pretty soon I had to start explaining to my mother how to surf. And that is my mother, by the way. Getting upset that I was taking her picture. And then along came the boom. Boy, oh boy, that was ridiculous. Irrational exuberance, claimed Alan Greenspan. VCs got interested. VCs threw money at anything, and it came back tenfold. Amazon.com came out there, tried to do a world's record in losing money, succeeded for quite a while. Sock puppets. Mike Odell was claiming that the internet traffic was doubling every 3 days or 3 weeks or 3 months or something or other, 3 somethings, and people believed him. It was quite a thing. IP over everything over IP. It was just stunning. Metronets, et cetera, et cetera, et cetera. But there was a problem. That's a real picture, by the way. That is a few nanoseconds before the bullet hits the balloon. Bang. About $1 trillion. That's pretty neat. It's about the same number of dollars, value-wise, as happened in the railroad crashes at the beginning of the century. About $1 trillion. Now, none of the major infrastructures, railroads, canals, telephones, or internet, paid for itself other than the telephones. The telephones paid for themselves because they're a regulated monopoly. It's wonderful what you can do when the government says you have to pay for the investment and to keep the prices high to do that. Nobody did that on the internet. Nobody did that in the railroad. So, bang. The world died. And it sort of trickled up. This is the psychological timeline. It sort of trickled up. And then, last month, Amazon.com said they had actually made a profitable year. A whole year, and then they didn't lose any money. I'm not sure it's the same company, but this is now starting to raise expectations a little bit. And there's a couple of lines there because it depends on who you talk to. Some of the VCs are now jumping in with both feet. They don't use their heads in this context, they just use their feet. And some of them are actually thinking about it and going slow, but it's starting to creep up again. So we're actually get back into it, back into the swing of things. It's up and to the right, but not as up and to the right. Along the line, we've had a bunch of diversions, things which have gotten in the way one way or the other. This is Charles Brown, or I think it is, Charles Brown, Chairman and CEO of AT&T. I'm not sure that it is because I went to try and find a picture of him on the AT&T website, and I could only find 2 copies of one picture, which was Charles Brown and somebody from the Justice Department shaking hands over the AT&T breakup. And I think this particular picture is Brown. It's nowhere else on the website. Since this was AT&T becoming, breaking up into little pieces, maybe they're ashamed of him and they don't have any other pictures of him. I'm not sure. But AT&T was telling Congress at the time that NSFNet and the high-performance computing stuff was being talked about being funded, that you don't need to do that. Don't need to fund that. The telephone world can provide that. It's called ISDN. Provide 64 kilobits of data connectivity to every desktop. No problem at all. That was a bit of a diversion. And then there was gossip and OSI, the OSI protocol suite. Whatever the question was, OSI was the answer. Corporations, governments, etc. And then there's Bob Metcalf and his parade column. He went off and he and I did dueling columns on this topic of whether the internet was going to collapse. He said it would. I said it wouldn't. The title of my column about him was "The Internet Through Doom-Colored Glasses." He didn't like that. My column claimed that actually a lot of the problem was the press, which, since the press doesn't vaguely understand what this internet thing is, it's all magic. They can easily believe the magic will go away and the whole thing will collapse. Something like airplanes not being able to fly and falling out of the sky. But my editor actually at my newspaper cut out that part of the column because he didn't really want me to dump on the press, even though that was actually the problem. And then there's John McQuillan. ATM is the answer. We don't even need a question. It's just the answer. Now, don't cry for John. John sold out of ATM just about the right time, just about the time people realized that it wasn't going to be ubiquitous like helicopters in your backyard, which Popular Mechanics claimed at one point. He sold out of NGN, Next Generation Networks, a couple of years ago. I asked him in November, during his last NGN meeting, well, what are you going to do? What are you going to do now that this is over? And he said, well, as of Friday, I'm a member of the Idle Rich. He's studying the mating habits of elk in Jackson Hole, Wyoming. There are things that I would do, but I don't think studying the mating habits of elk is one of them. And then Jack Valenti, who thinks that nothing over the net should be copyright free, and that you don't own anything, it's all rented, and wants to make sure that you, the ISP, help him in his endeavors. Whether the Digital Millennium Copyright Act says they don't have to or not, Jack still wants you to help, and he's such a nice fellow. And then there's Disney, who keeps getting the copyright term extended. The Constitution says that it's for a limited term. It's now life of the author plus 90 years. Limited is in the mind of the beholder. In the case of Disney, it just has to stay as long as it has to increment over time to the same rate as time does relative to the Mickey Mouse. This is a still from the original Mickey Mouse cartoon, Steamboat Willie, and it sort of shows the grounds on which Michael is standing on. And then, of course, there's John. The answer is national security, but I can't tell you what the question is. We're all under the microscope. This is going to be a major effect going forward, and Diane talked about it. She made a slip of words in that she said that the government was trying to combat the internet. I think she meant combat problems on the internet. But actually, combat the internet is exactly what early folks, back 15 years ago, exactly what the law enforcement wanted to do. They wanted to combat the internet. They didn't want it to happen because it wasn't controllable. It wasn't something they could watch over and do what they're supposed to do, which is to keep us safe and secure and all of that. And the internet doesn't make that happen. Doesn't make that easy, and it's not going to be easy going forward. We're not going to just be able to say national security and therefore you should do X, because X is not very well defined, no matter what we do. Innovation. This internet thing, people think it's innovative. Is it really? This is from a PBS show. It was back during the Millennium celebration. It basically says there's nothing new. There's effectively nothing new since 1900. Everything is just engineering. Moving pictures and sending your voice and all. It's all just engineering, simply engineering. One does want to innovate. If you can't see the picture here, this is an experimenter in a psychology experiment sticking his tongue out at a little baby, and the little baby is sticking his tongue out back at the experimenter. Imitation's a good thing. It helps you learn if you happen to be a little baby. But we're seeing too much innovation, too much imitation disguised as innovation on this thing we call the internet. What is new since 1900? Well, the web, sort of. Instant messaging is, because telegraph, while it was instant, didn't go to the individuals. Remote login, but everything else is just engineering from what we'd had before. How important and how different is e-commerce? Well, Sears and Roebuck did a pretty good job. Next to Amazon, actually they had a pretty remarkably diverse catalog for a rather long time. And all that Amazon did was change it from a postal-based system to an internet-based system with dealing with the instant gratification requests that we have these days. It didn't really change the paradigm much at all. So is that innovative? I don't think so. A big problem we're having today is that the folks who are starting to bring us VoIP, voice over IP, like Vonage, can't do something that doesn't look like the telephone network. If you go look at Vonage's ad on the web, if the net is up and people aren't running as a base station anymore, so you can actually go and look at Vonage's ad on the web. You can't distinguish it from Verizon's. We'll start with V, and they both list the same set of services. They're imitating the phone network. And if you're imitating the phone network, how are you doing innovation? There's nothing innovative there at all. The ITU and various government agencies want to define what voice over IP is. They want to define it so they can regulate it, so they can understand it. But you don't have the faintest idea what voice over IP will be in 5 years. But the folks that are trying to bring this thing to you can't get away from it's got to be what we already know. We've got to be something which has been constrained in its architecture by a 9-button keypad or 12-button keypad. Somehow that's not the future, but that's what they're understanding. So I was talking to the telecoms regulator of Spain a couple of years ago, and she said, this voice over IP stuff, not very good. Getting better. As soon as it gets good enough, we're going to regulate it to be sure it stays good. I said, sounds like a really good reason never to get it quite good enough. She didn't understand it. But she said, I know it's not very good because when I use it to talk to my in-laws in Seattle, it's not very good. But she is using it to talk to her in-laws in Seattle. It's good enough for that. She didn't get it. She fundamentally didn't get it. You can't never underestimate the power of free, first of all. But still, if you've ever read Christensen's Innovative Dilemma, the fundamental there is that there's a whole class of applications where the provided services are far higher quality or far more expensive or far faster or whatever than a huge chunk of the user community. And the internet has shown that you can provide services that are good enough for a huge range of applications. They're just not the cutting edge. Well, that's good enough. If you've got a cell phone, then you understand this phenomenon. Then we've got these carriers saying they're doing new networks. Sprint put out a press release just a year ago now, which happened to contain information from a press release 2 years before, which said that they were getting internet ready and IP ready, and really what it meant was they're deploying ATM. This is the future. This is people who like circuits. If you're a circuit fan, ATM is your friend. And now we've expanded that acronym by 30% and made it so it's 30% better. We call it MPLS instead. Verizon, SBC, and Bell South are trying to do this fiber to the home thing. But what are they doing? They're coming up with a standard for passive optical Ethernet, which is everything is controlled by the carrier. Everything is not point-to-point on this passive optical Ethernet. Everything comes back to the carrier, and the carrier controls it entirely. So it's back to the circuit world. It's just putting circuits as photon trails over glass instead of over copper. What would be innovative? Well, I don't know how many here know much about iMode. iMode is a phone service in Japan done by Docomo. The iMode uses smart terminals. You download Java applications to it. Uses open interface to the internet. It's not a gateway. It's not a wall garden. It uses open standards. It uses a reduced set HTML, but it's a W3C standard. That's not innovation, but it allows for innovation. When you have a wall garden, it blocks innovation. If you have blockages between the ends, it stops innovation. iMode allows innovation. It is not innovation itself. The president of iMode said his toughest fight within iMode was when the people at Docomo, his parent company, suddenly figured out that they were using the little phones, the cell phones, to talk to e-commerce sites. And the folks at Docomo wanted to not allow that unless Docomo had a business relationship to that e-commerce site so they get a piece of the action. And the president of iMode said it was his toughest fight to get them to not do that. But he won, and right now the only thing that they're charging for is packets. They charge for packets. They also, if you want to, use their facilities to do billing. They'll do billing for you for 9%. But they're not getting in the way. They're letting you do something. One of the biggest services on iMode was Hello Kitty. I don't know how many of you know what Hello Kitty is. It's cute little cartoon characters. They had 1.6 million subscribers. Not iMode, but the Hello Kitty people had 1.6 million subscribers to Hello Kitty service, which downloaded cartoon characters to your cell phone. $1 a month. So iMode's getting 400 grand a month for that. The Hello Kitty people are clearing 1.3 million a month for cartoon characters. What businessman in his right mind would have decided that that was a good venture? But it was, and it was enabled by the end-to-end functionality that iMode allows and the end-to-end functionality that the internet allows most of the time. What's the internet today? Sad to say it's not what it was. Can't really see it, actually. This is the feature of these things. Behind that wall in the upper left-hand corner is China. It's supposed to be translucent, and there's China behind there. There's little teeny holes poking out. You can't really get to China from the internet. China controls it. The internet is no longer transparent. We've got firewalls and NATs and all kinds of things getting in the way between here and there, therefore inhibiting our ability to innovate. It's a fact of life. We have, as we heard earlier, people do put up firewalls, companies do put up firewalls. It makes them feel better. Doesn't change the security picture hardly at all, but it makes them feel better. And it makes their auditors feel much better, because in auditing school you have a checklist that says, do you have a firewall? Yes, no. If you have a firewall, then you're okay, and if you don't have a firewall, no, you're not okay. Not much in the way of security, a lot of Wi-Fi, firewalls with port 80 going through. So you can run anything over port 80, and if you haven't seen it, RFC 3093 is an April Fool's Day RFC of running TCP/IP over port 80. So let's cut out the middleman and just run the application over that. The recording industry, the grid, MPLS, as in Randy Bush's immortal words, is a local black hole for doing the local gravity well. Everything that's swooping to MPLS, that's reduced a little bit than what it used to be. Spam, ISPs not making money, et cetera, et cetera. So that's the internet of today. What about the internet of tomorrow? What are we faced with? We've seen the history, gone back to the mid-60s. Now what are we seeing for the future? Well, here's one alternative. It's a government-centric alternative. The U.S. government thinks that they built the internet so they own it. And there's a lot in Congress that truly believe that. None of this international stuff. It's far too important for the geeks. It's far too important for anybody who knows what they're doing to be involved in deciding what to do. But that's a feature. I don't know how many of you know about WSIS. You should. you won't like what you know. You won't like it when you find out about it. But WSIS is a World Summit on Information Society, and they think that they are going to set up Internet governance for us. They're going to tell us how the Internet's supposed to run. Then Department of Homeland Security, European Commission, et cetera, et cetera. Then there's another view, which is a carrier-centric view. It's all the carriers, and they're going to do voice on demand, and it's content, and content is king. But as Andrew Lusenko says, content is not king. Content is actually a small percentage of the value chain here, but the telephone companies can't seem to get that through their skulls. I'm sure I know a lot of you from telephone companies. I'm dumping on your business, but that's the way it goes. Another alternative, we'll go back to where we started, in UUCP and the like, community networks. That's a picture of 9,669 open wireless nodes in Manhattan. That plus community nets put up like Project Utopia in Colorado, which is fibering the communities. This is going back to the future. Or we can look at the telephone model. This is a slide from a telephone company presentation, which says that the best endeavors internet, this is Australian presentation, so it's best endeavors, not best effort, will be paralleled with a carrier-provided IP, carrier-grade network, IP network. Maybe again, you guys are going to survive and actually give us an internet which isn't just a Disney-controlled TiVo, but actually has some internet in it. The internet has quite a future if there's some internet in it. Next, there's a bunch of decisions that I think were actually quite critical in getting us to where we are today, existing networks, et cetera, et cetera. ISO turned down TCP/IP, so it's not a government mandate, no government organization controlled standards body. The IETF does this standardization. NSF forced an AUP, which forced people to actually build a commercial internet. We've had almost no regulation. We're making some decisions today. How open is the path? Are we going to blow a hole through that wall to China? Are we going to have it open? Or are we going to do what Panama has done? Panama has regulated voice over IP, first trying to block it, and then just recently said voice over IP is the same thing as regular telephony, even though we can't say what voice over IP is instant messaging voice over IP. Two key open questions: who says who makes the rules, and who says who pays for what? WSIS is going to try and answer those. And that you're not going to like the answer. It is now. It is us. We have to be part of this decision. And I'm almost optimistic.